So I told you to look back at your families of functions, or you could have just graphed the first one. 1 over x looks something like this. Everyone agree with that from either a calculator or a note card? And remember, referencing those note cards will be quite handy when you're studying for the final. We did some of these when we did transformations, but these were always the hardest for you because it's kind of hard to tell what's inside and outside. But if I throw in some parentheses here, can you now tell what's with the x? So, how is f of x moved from the original f of x? Right one. Everything's picked up and moved right one. I'm going to move the vertical asymptote. What is a vertical asymptote? A vertical asymptote is a line that a graph approaches. Good, but it doesn't touch a vertical asymptote. A horizontal asymptote actually can be touched, so that's why I like to use the definitional line that the graph approaches, not a line that the graph doesn't touch. They're kind of guidelines for graphing. Okay, any questions about the blue one? Okay, let's make this one red. How is it moved? Right one and up 3. So from this one, it's just moved up 3. I'm going to pick up, do you see the horizontal asymptote here? I'm going to pick it up and move it up 1, 2, 3 units. And then I'm going to go off of the blue vertical asymptote. So I'm going to pick each point up and move it right 1 and up 3. And so from the blue, it's just moved up 3. Okay, any questions about that one so far? Did your calculator show you the whole sketch? Some of you are nodding yes, some of you are nodding no. Some of you, it probably stopped at the asymptotes. Is that true? So you have to know to continue it on, to know that there's an asymptote there, if your calculator is not graphing it real well. This one, what does a negative do? Reflects it over the x-axis, and then a 2 vertically stretches by 2. So from the original, this negative 1 will be at a positive 2. Will the asymptotes move? No, because 0 times anything stays where it is, right? This positive 1 will be at a negative 2. The asymptotes of 0, y equals 0 and x equals 0 stay the same. So mainly a reflection on that one. Otherwise, graphically, you probably wouldn't have noticed the stretch if you just put it in your calculator. But you would have noticed the reflection. Okay, so today we're going to be looking at rational functions. A rational function is one where the numerator and denominator are polynomials. Rational function is one where the numerator and denominator are polynomials. Right now, we can graph a function only if it's in transformation format. That's all we know how to do right now. So today we're going to look at rational functions a little more in depth. Lily, I think y'all's table has gotten scooted up again. If y'all want to move it back for a better view, feel free. It kind of gets scooted. Anytime you need to do that, if I don't think to say something, just if it gets too far up, you just move it back. And actually, Nate and Lily, since there's only, I have a few seats that I didn't have. The seat by Jessica's empty, and the seat over here by Shane is empty. If y'all ever decide you want to move, since we have free seats. Just some quick definitions. Vertical asymptotes are straight lines of the equation x equals a number toward which a function approaches but never touches. So Chris said that earlier. Y'all have heard of vertical asymptotes before, right? In some other class. So they are vertical lines where the function approaches but never touches. Horizontal asymptotes are horizontal lines, so they're y equals equations, toward which a function f of x approaches. Horizontal asymptotes may be touched or crossed. So a common misconception with asymptotes is that you can't ever touch an asymptote. Horizontal asymptotes can be touched or crossed. They are just approached as x goes to infinity or negative infinity. It is very similar to end behavior of a polynomial, what the end of the rational function is doing. Domain is a set of all x values. When you are looking at a rational function, we're going to ask ourselves, what can x not be? And with a rational function, which is a fraction, what do you know that you cannot divide by? What is it against the rules to divide by? A thing in your calculator that when you try says error, you can't do that. 0, you cannot divide by 0. Everyone agree with that? Try it. Do y'all know why you can't divide by 0? I want to know why you can't divide by 0. Anyone can? So if you have 3 divided by 0, and let's pretend that equals a number. Just for pretend. Pretend there is some number where 3 divided by 0 equals that number. Wouldn't that mean that 0 times that number equals 3? What is 0 times anything? See how that just doesn't work? See how that just doesn't work? You cannot divide by 0. That's why it's against the rules. Okay, so when we're looking for domain, we're going to look for all the x values that don't make the denominator 0.
Staff, please pardon the interruption. I need to see the following students in high school office. Rachel Bree, Ashley Robbins, Ashley Whitlow.
Okay, to find vertical asymptotes, we're going to factor the numerator and denominator, and we're going to look at when the denominator equals 0. However, factors that cancel don't make vertical asymptotes. They make what are called holes in the graph, and we're going to look at some of those. Any factor that doesn't cancel makes a vertical asymptote. So for now, write this down. In just a second, I'll show you examples. It'll make a lot more sense once you see an example. You're writing. Okay, I want to talk a little bit about these before I do some examples about why they are what they are. The first one is the degree of the numerator is smaller than the degree of the denominator. So something like x squared over x cubed. Everyone agree with that? That's a smaller degree on top than on bottom. This could have more numbers out here. A horizontal asymptote is what's happening as x approaches infinity or negative infinity, or as x gets really, really big or really, really small. Very similar to end behavior on polynomials. But you remember on polynomials, the only thing that mattered were the first term, was the first term. Everyone agree with that? I kind of call it the Bill Gates principle. As x gets really, really big, does he care about $2? No, it's just immaterial to him. It doesn't matter, right? Now, that's not the case when x is small. When you have a small amount of money, that $2 is a big deal, right? So it depends on where you're at on the function. But as x gets really, really big, the only thing that matters are the first two terms. And as x gets huge, what happens if the number on the bottom is bigger than the number on the top? What happens when you divide by really big numbers? Yes. And why? What happens when you divide by huge numbers? What's 1 over 1,000,000? Try it in your calculator. Do 1 divided by 1,000,000. Maybe just do 1 divided by 100 first so you kind of see what's happening. Isn't it 0.001? Or 1,000,000 is 0.000000001, right? Don't you get little numbers? Tiny towards 0? So that's why when the denominator is bigger, you get a horizontal asymptote of y equals 0. If the numerator is larger, so if you had an x cubed on top and an x squared on bottom, then there is no horizontal asymptote because that does not level off to any number. It goes to infinity or negative infinity. And then the last case is if the degrees are the same. If the degrees are the same, and as x gets really, really big, remember the first two terms are the only things that matter. What is 3x cubed divided by 2x cubed? 3 over 2? So the horizontal asymptote will be 3 over 2. Because as x gets really, really big, these numbers don't matter. And so you get what's called the ratio of the leading coefficients. That's just a fancy way to say the 3 divided by the 2. So that is the horizontal asymptote if your degrees are the same. So we're going to walk through some examples. We're going to find domain, we're going to find vertical asymptotes, we're going to find holes, and we're going to find horizontal asymptotes. And I have two examples here that are very, very similar. I did that on purpose to kind of compare them. The first thing I'm going to do is factor the denominator. Anytime you come to a rational problem, rational function problem, we want to factor the denominator. You agree these denominators are the same? What do they factor to be? Good. X plus 2, x minus 3. If you have forgotten how to do that, what else can you use? Your calculator will factor quadratics for you, either in quad 3 or in factor poly. If you're color calculator, you'll have to use quad 3. If you have the regular calculator, you can use factor poly. Y'all know what I'm talking about? Nod your head if you know. Alright, so let's talk about domain. Remember, domain is all the x values, or what x can be. So you tell me, what can it not be and why? What can x not be? What can't be 0? 0's okay. I can plug in 0, get 1/6. What can't be 0 though? He's on the right track. What'd you say? The bottom can't be 0. Everyone agree? Because I can't divide by 0. What makes the bottom 0? 3 and -2. So x cannot be 3 and x cannot be -2. There are two ways to write the domain, and you need to know and understand both. They actually mean the same thing, but you're going to have to pick it out on multiple choice. There's set notation, which is the easy way to write it. I actually don't want you practicing set notation because I think you could all pick that out. Does everyone think they could pick that out on multiple choice? X such that x doesn't equal 3 and -2. Again, that's not the way I want you to practice on homework because I think you could do that without practicing. The way I want you to practice is interval notation. And to get interval notation, I'm going to take those two numbers and put them on a number line. We have used interval notation before. It's the infinity stuff. Would you agree x can be anything except those two numbers? So x can be -infinity all the way to -2, -2 all the way to 3, and 3 all the way to infinity. So the other way to write the domain, I highly recommend using a number line to help you with this. What do you think people who don't use a number line forget often? The -2 to 3, they leave that out. They go -infinity to -2 and 3 to infinity. They leave out the middle piece. Do you see why you need the middle piece? You can plug in 0, you can plug in 1, you just can't plug in the numbers -2 and 3. So both of these are correct. These are completely interchangeable. I want you to practice interval notation because it's harder. Y'all agree it's harder? Interval notation a little harder? So I think it's what we probably need to practice. Okay, vertical asymptotes. We find those when the denominator is 0. However, we have to watch for something. We have to watch and see if anything on the top cancels with anything on the bottom. Do you see this x minus 3 on top and bottom on this function? On this function, the 3 is not a vertical asymptote because it cancels, it makes a whole. So the vertical asymptote on this one is only x equals -2. Mental note. Well, don't mental note. Write it in your notes. If you don't write x equals on this, I will count off. Why would I do that? What is a vertical asymptote? Read it out from your notes. Isn't it a vertical line? What's the equation of a vertical line? Good. X equals. A vertical line is always x equals a number. And so because of that, you have to write the x equals or I might think you're writing a horizontal line. Does that make sense? And so the vertical asymptotes on this one, does anything cancel on this one? No. So both the x equals -2 and the x equals 3 are both vertical asymptotes. Does that make sense? This one has no holes because nothing canceled. This one has a hole at 3. Where do you think the hole came from? The x minus 3 that canceled. So the holes are the things on the bottom that cancel. Is anyone in here going to take calculus next year in college? Is anyone in here going to take calculus next year in college? No? Curious. If you were, the y value of the whole becomes an important thing to find. If no one's going to take it, I'm going to skip that because you don't need to know it for college algebra. Okay. Horizontal asymptotes. How are we going to find a horizontal asymptote? Follow the rules, right? What rules am I talking about? 1, 2, and 3. So the first thing I look for is the degree. And on both of these, what do you notice about the degree on the bottom? It's bigger than the degree on the top. So what is the horizontal asymptote? Y equals 0. Okay. Any questions about that one? We're going to do some more examples. Okay, try this one. I even factored it for you, just for time purposes. So see if you can go through and find the domain in interval notation, the vertical asymptotes, the holes, and the horizontal asymptotes. So there's a lot of rules to follow, but once you know the rules, you're good to go. Did everyone get a worksheet? There. Okay. What's your question that you're asking yourself when I ask domain on a rational function? What do I ask myself? What can x not be? And what can it not be? Good. X can't be 3 and -3. I'm going to find that out before I do any canceling or anything, because I know that if I plug either of those things into the function, it makes the bottom 0, and my calculator would say error. Those will be the places where vertical asymptotes show up, maybe, or a hole. I am going to draw a number line really quick to help me with my interval notation. What is the domain once I draw that number line? -infinity to -3 parenthesis, because I don't want to include the -3. If you put the u's or don't put the u's, I don't care. I'm not going to count off for that part. And then what? And then what? Perfect. Vertical asymptotes, what would they be? Why not +3 also? Good, and so that part cancels, which makes a hole. So I have a hole at x equals 3. The hole will look like a point, and I'll show you that tomorrow when we start graphing. Today we're just picking it out, just finding what x value it exists at. No, the other way. It's what makes the bottom 0 and the one that does not cancel. So you see how it makes this 0, x equals -3 makes this 0. That's where the vertical asymptote comes from. This one cancels, so it's a whole. Now, I think what you were thinking is this one's negative because it's x minus, but remember what x value makes this equal 0. So that's why the whole is the positive and the vertical asymptote is the negative. Good question. The whole and the vertical asymptote both are what make the denominator 0. The wholes are the ones that cancel. The vertical asymptotes are the ones that don't. Did that make sense? So if I go back to this slide, this one had 2 vertical asymptotes at both pieces. This one, since the x minus 3 canceled, the -2 was a vertical asymptote, but the 3 was a whole. That makes sense. What about the horizontal asymptote? Okay, good. This one has the leading, the degrees are the same, right? Everyone see how I know that? The x squared over x squared. So the horizontal asymptote is the ratio of the leading coefficients. 1 divided by 1. And what is 1 divided by 1? So y equals 1 is the horizontal asymptote. You could graph this function and make sure you're right. I would hope that if I graphed it, don't back up yet, I've still got like 10 minutes. If I graph this, I would hope to see some kind of vertical asymptote look at -3 and a leveling off at y equals 1. So I would expect to see something like that, yes. It's only the places where the bottom equals 0. Did everyone hear Kyle's question? The top equaling 0 actually makes an x-intercept, which we'll talk about another day, because it makes the whole thing equal 0. So when y is 0, you have x-intercept. Well, these 4 things are probably enough for one day, so we'll hold that. Okay, domain on this one. What am I asking myself for domain? What can x not be? What makes the bottom equal 0? Well, what does make x squared plus 9 equal 0, real number-wise? What number?
3.
Let's try it. What is 3 squared? What's 9 plus 9? Okay, what's -3 squared? It's also positive 9, isn't it? So actually, if you go to solve this equal to 0, would you agree you get imaginary numbers? For domain, I don't care about imaginary numbers. So this domain is -∞ to infinity or all real numbers. What does that immediately mean for vertical asymptotes and wholes? None. If the bottom doesn't equal 0, then I never have a vertical asymptote, I never have a place where x doesn't touch, and I never have a hole. What about horizontal asymptotes? Also none. Why on that one is there none? The numerator is bigger than the denominator. Does that make sense? That one was kind of a strange one. Let me see if I have an example. Before I do that example, something that always trips people up, and I always underestimate it. I'm just totally making this up. But if this is on the bottom, what factors? An X factors out. For some reason, we have a hard time with that one. So what would make this equal 0? I just made this up as a bottom. What would make that equal 0? You might have to do a side note, right? X equals 0, which works, and then 3x minus 1 equals 0. So add the 1 over. X would be a third. So if your function looked like that, you would have vertical asymptotes at 0 and a third. At x equals 0 and 1/3. Does that make sense? I just wanted to throw that out because for some reason those greatest common factors get us sometimes. Okay, let's look at this one. I need to factor both the top and the bottom. The top has a greatest common factor of 2. Is that as far as I can factor the top? No, we could do a difference of perfect squares. If the top does not factor, but the bottom does factor, would you agree they probably have nothing in common? No common factors, so probably everything on the bottom is a vertical asymptote if the top does not factor. Okay, domain. What are my two things that are not included in the domain? Good, -2 and 2. So my domain is -infinity to -2, -2 to 2, 2 to infinity. Any questions about that part? What are the vertical asymptotes? Good. If nothing cancels, isn't this same thought the vertical asymptotes? If nothing cancels on top? If something cancels, that's the whole. Since nothing canceled, there are no holes. And then what is the horizontal asymptote? 2. Y equals 2. How do I know it's y equals 2? The degrees are the same. It's the ratio of the coefficients. So you see your homework looks like this. These 4 questions asked on some problems. The hardest thing about this is factoring, but don't forget if you get stuck on that, you have a calculator to help you. So if you have a problem with one that's not factoring well, if you put it in quad 3 and it gives you imaginary answers, then it doesn't factor, right? There are no places where the denominator equals 0. If it gives you decimal answers, you can put down decimal answers. That's fine. Which I don't know that any of them do, but if they did, you could put down decimal answers.